Hello and welcome back to the show. I'm your host, Doc Frank. Today's episode is a bit out of the ordinary. I don't have a guest for a conversation, but I'm reporting from a recent conference that I attended, the Urban Rail 2024 in Brisbane. Now, I wasn't at Brisbane. I was 3,600 kilometers away, roughly in Perth, but kudos to the organizers of the conference, Informa Connect. This was a hybrid event. So that means there were people in the conference room in Brisbane attending the whole event live. And there was also a possibility for virtual participants to attend the conference remotely. And this is what I did from the other side of the vast country, which is Australia. I did not attend the entire conference, which was probably a bit of a bummer because the lineup of speakers was very, very, very impressive. So again, great job by Informa to put together a very, very interesting event with a very wide range of topics, including light rail, including level crossings, including project updates from all over the country. It was really, really good. And the one part that I did not want to miss at any cost was the very last of the conference, because there were at the end a couple of presentations about ETCS, about two applications of ETCS, which I personally think are two of the most sophisticated and more advanced ETCS applications in the world. Interestingly, both of them are outside Europe. One is the Digital Systems Program in Sydney, Australia. The other one is the first commercial application of ETCS Hybrid Level 3 on the Regional Rapid Transit System in Delhi, India. Specifically on the first line of that new network, which runs from Delhi to Meerut, which is a regional center about 80 or so kilometers, 85 kilometers or so outside of the Delhi city center. So what I want to do in this episode is look at these two ETCS presentations and comment on it. So give you my views on it, explain to you why I think those two ETCS applications are amongst the best and most impressive ones in the world. I hope that if you're interested in ETCS, that will really be a field day for you, highly interesting. And as usual, if you like what you see here, if you think there's somebody else who could benefit from it as well, please do me two favors actually. Number one, please subscribe to the show. Number two, tell a friend about it. And if you tell 2 or 3 friends about it, I would not mind either. Thank you very much. So with that, let's go into the first of those two presentations. Hi, this is Doc Frank again. I need to tell you about my brand new online ETCS training. It's the online version of the well-proven ETCS Kickstarter live training that has helped more than 200 railway professionals in Australia and New Zealand, regardless of their prior knowledge of signaling. So that really means you can learn the fundamentals of the European train control system, even if you didn't have any signaling knowledge before the training. How good is that? There's an online study group for networking during the training, and I also provide an industry-leading support of questions and answers, not just during your training, but also for a guaranteed minimum of 12 months after the training. Sign up now at docfranktraining.podia.com/ETCS. That's docfranktraining.podia.com/ETCS. I wanted to take clips from both presentations and comment on that. Unfortunately, the first presenter didn't want me to present clips from her presentation because she was concerned that the client organization may not want that. that online representation, even though it's mainly positive. So what can you do? I mean, I do respect the request of my guests, so I'm not covering the first presentation with clips, except I'm going to show 3 slides from that presentation because they are just better illustrations of what I want to talk about. Before I forget it, a big thank you and a shout out to Informer's General Manager Transport, Tina Karas, and also to the conference organizer of Urban Rail, Diana Lausi. Thank you very much for letting me do this. Now, this presentation I'm going to talk about now is from one of the 2 suppliers of ETCS Level 2 trackside in Sydney. That's Siemens. The other supplier, in case you wonder, is Alstom, and we will get back later to a presentation by Alstom because they were also the supplier of the hybrid level 3 in Delhi. So the first slide may surprise you a bit because it's a comparison or a consideration why ETCS level 2 was used in Sydney for the Digital Systems Program and not CBTC. Now, why do I say this may surprise you? Because normally you have a quite clear delineation for certain types of railways that are using CBTC. Those are usually metro railways in a tight city concept. Think of the likes of London Underground, Paris Metro, Singapore Metro, Hong Kong Metro, things like this. And then you have the so-called mainline railways that use normally rather ETCS. And the European Core Network is one example of that. Now, the thing with the suburban railways in the Australian cities is that they are kind of a hybrid. So they sit somewhere in between. They, on the one hand, come certainly from a mainline background, and many of them share the tracks with freight traffic, so they are definitely mainline railways from a pedigree point of view. On the other hand, they want to increase capacity, or they need to increase capacity, ideally into areas that are normally reserved for applications of CBTC. So that's why in Australia we have the curious case that a comparison, a technology selection between CBTC and ETCS is actually a thing. And we have examples in Australia, Perth for example, where CBTC was selected over ETCS. What is also special about Sydney, and important to know if you don't know already, is that Sydney has 2 separate rail networks. One is the suburban network that we are going to talk about here. The other one is the completely separated network of Sydney Metro. Sydney Metro is operating a driverless metro service, and they're using CBTC for signaling. However, on the suburban rail network, which is operated by Sydney Trains, over the last few years they implemented a simplified version of ETCS level 1 in limited supervision, and accordingly it would be much easier to now introduce ETCS level 2 for capacity improvements compared to CBTC. So CBTC obviously would not be compatible, would not be interoperable with ETCS level 1, whereas ETCS level 2 should fit much better to ETCS level 1. Another reason for preferring ETCS over CBTC for the suburban network, which is shown here on the slide, is that it's better suited for mixed traffic. I told you already that some lines in Sydney of the suburban network share the tracks with freight movements, with freight trains. And for this kind of application, which is kind of similar of what you have in most of the European countries, ETCS is by default the much more suitable technology, much more suitable than CBTC, because metros normally don't share tracks with freight trains. Another aspect here is interoperability between suppliers. So I already mentioned there are 2 ETCS trackside suppliers in Sydney right from the start, Siemens and Alstom, and the interoperability between those two was a main objective for the project right from the start. And it's one of the most outstanding features of this ETCS Level 2 introduction in Sydney. And then lastly, one of the main requirements for ETCS is ease of migration. So getting from an old legacy signaling system to an ETCS Level 2 CAP signaling system is usually easier to achieve than migrating from a legacy signaling system to CBTC. This next slide that I'm showing you here is about a very important aspect of the concept for ETCS Level 2 in Sydney. It's a radical simplification of trackside infrastructure, especially signaling infrastructure. So on the left-hand side of this slide, you see an overview of all the existing signaling equipment that you have currently along the track on the Sydney suburban network. Of course, you have signals, and you can see them here in the left picture. You also have mechanical train stops. So that's the white box that you can see there right next to the tracks between the signal and the rails. You have track circuits for track vacancy detection. You also have warning lights, which are part of the signals. You have guards indicators on platforms, and obviously you have lots and lots of cables to connect those signaling equipment with the interlockings. And one special thing that you see in red at the bottom of the slide, in the bottom left-hand corner, are impedance bonds. Now, this is a specialty that you have in Sydney because of their use of 1500 volt DC traction current. So you need to have impedance bonds to make sure that you don't get any issues with the signaling equipment on that power supply. On the right-hand side of the slides, you see how much simplified, how much easier the equipment is for the new world of ETCS Level 2. So all you have there are marker boards or virtual signals, and you can see them on the right picture, those yellow arrows on blue background. And the only other things you have in the track are Excel counters for track vacancy detection and balises, Euro balises for ETCS Level 2, and they are fixed balises, so you don't need any cabling there. What's actually missing on the left side of the slide, which is also part of the simplification of signaling, I told you that they have recently rolled out ETCS Level 1 limited supervision on most parts of the network in Sydney. The trackside equipment for ETCS Level 1, especially the line-side electronic units sitting on the signals, they can disappear as well once ETCS Level 2 is introduced. The reason why this is missing on the slide here is probably because on the first project that Siemens is doing in Sydney, there is no installation of ETCS Level 1. They just left it out of the scope because they knew that Level 2 would come in the very near future, though they haven't really fitted Level 1 on that line. So therefore, Siemens, when introducing ETCS Level 2 on the line between Sutherland and Cronulla, they didn't face an existing ETCS Level 1. So the effects of this simplification of trackside infrastructure are really, really big. So one is there's a huge impact on reliability, availability, and also maintainability of the signaling equipment. Obviously, all the equipment that can be taken out doesn't need to be maintained anymore. It cannot fail anymore, so that improves the availability of the entire system. And with that, you also gain additional reliability of your services in Sydney. One additional aspect is that Excel counters have a reputation of normally being more reliable than track circuits. So that replacement from track circuits to exit counters should also help with that. The other important thing, and this is at least as important as the improvements in availability and maintainability, is getting rid of signals. Getting rid of line side signals allows for refining the layout of your block sections, of your exit counter block sections, to optimize them for capacity and not for signal sighting distances and things like this. So that's another key feature of the concept of digital systems in Sydney in order to improve capacity and make the existing capacity of the signaling system more reliable. The third and last slide I want to comment on of this presentation is a simplification of the equipment rooms, of the signaling equipment rooms. So on the left hand side you see a picture of how it looks at the moment. You've got lots and lots and lots of relays for signals, for the control of train stops, for the control of track circuits, and obviously a very excessive amount of cables, again, to connect everything, both with the interlockings and also with the outside, with the field equipment. On the right hand side you see a much simplified layout where one location case replaces 9 signaling equipment rooms. So you see a massive simplification and also a big centralization, because all the interlockings will be in one central location, not just for the line where the interlockings are built for, but for the entire Sydney network. So all the interlockings that will come in later will sit in the same centralized signaling equipment room, and that obviously gives huge advantages for access, for maintenance access to those interlockings. If anything should go wrong, then the maintainers can basically sit next door. They don't need to travel for extended period of times in the Sydney rush hour to rectify any mistakes, any failures. One consideration, obviously, if you have more centralized equipment, the requirements for availability go up, simply because if anything happens, then the impact would be much bigger if you have a larger control area concentrated in one place. Before we go to the second presentation, I want to highlight a couple of other concepts in Sydney that are very worth noting. One is the migration concept. So you saw on the slide with the trackside simplification a move from track circuits to exit counters. And this is not just to do with higher reliability of exit counters. There's another huge benefit regarding the migration from the old signaling system to the new signaling system. What you can do with exit counters, you can overlay them to an existing layout of track circuits. And this is something you cannot do with additional track circuits because they would interfere with the existing track circuits. So the move to exit counters enables the railway to be operated on an ongoing basis with the old signaling system based on track circuits, and at the same time introducing the new signaling system with exit counters. So that's really a massive advantage for migrating the railway from legacy signaling to ETCS level 2 with exit counters and of course with new interlockings. The second thing I want to mention is the use of 2 ETCS trackside suppliers right from the start. I think this is by far the best way to make sure that you end up with at least 2 suppliers that are really interoperable. We will see in the next presentation, which started off with a single supplier, how this compares to this approach in Sydney with 2 suppliers and what the potential problems can be for a railway that only starts with one single supplier. The second presentation, which will include clips, is from Vijay Kesavan. He used to work for Alstom in India as an engineering manager for the first commercial application of ETCS hybrid level 3 worldwide. Interestingly, he recently moved to Sydney, so he now also works on the digital systems program, which I just covered in the last part of this episode. But the presentation is about what's happening on the Delhi to Meerut line in India, where the first application of ETCS hybrid level 3 is done. I want to start with two clips that I've taken out of sequence. The first one is a video that was shown during Vijay's presentation, and I think that's really a very good starting point for this entire section of the episode. And the second one is an explanation of hybrid level 3, which I think is also important for you to set the scene for everything that's coming after that. Maybe one more comment here for the listeners to this podcast that don't have the video version. Normally, I do my best to have material that's equally suitable for video watching and for listening on audio. This is slightly different this time, so I've shown a few slides and now I'm also showing a video, which obviously you have trouble consuming when you only listen to the audio version. So I apologize for that. You can obviously go to the video version on YouTube to enjoy the whole thing with the images. What I want to do with this video here is to provide you with a voiceover rather than playing that fancy music at full volume. I'm doing a voiceover as well so that the listeners do have an understanding at least what's shown in the video. India's most advanced signaling solutions for trains by Alstom. India's first semi-high-speed train, NRCTC's Rapid X made by Alstom, is the world's first train to offer European Train Control System Level 3 hybrid technology over LTE, setting a new standard in signaling for superior safety, efficiency and interoperability like never before. One of the world's first trains to use LTE technology for smoother train communication. It comes fitted with integrated platform screen doors that comes with a stopping accuracy of 30 centimeters. Not only this, the signaling system ensures a gap of 180 seconds between two consecutive trains by virtual block implementation to help eliminate accidents. All train operations are monitored through a state-of-the-art control center setup or centrally controlled traffic operations on the network. The train made by Alstom is going to transform the future of regional commute in India. Oh well, that was not fun. The video's watchers could see that I struggled with the voiceover because the text in the video was just too fast. Or maybe I'm too slow a reader, I don't know. Anyway, let's now go to the clip where you hear the original voice from the presenter Vijay, and I don't need to do any more voiceovers because I didn't like that very much.
So what is ETCS level 3 hybrid? In a block section, you can allow only one train. So ETCS level 2 solution is a fixed block section. You can allow only one train in a section, and then you need to wait until the section is cleared and you can allow the other train. But in ETCS level 3 hybrid, in one section, in software, we managed to create a virtual sections, which should be at least minimum of one train length. And within the virtual block section, our RBC will enable to check the train presence, because the train is going to send the position report to the RBC. It also sends the length, what is the maximum front length and what is the rear end. So RBC able to calculate the total distance where the train is located in the virtual block section. So when the information received from the train, RBC able to manage, and it can able to build the movement authority. Movement authority, which is the information which managed from the track side to onboard. ETCS is a distance to go system. The trackside system will provide how much distance the train can go safely. So those information will be displayed in the driver DMI, driver machine interface. So based on the virtual block section, RBC will send the movement authority, and then the train can follow the other train closely. What is the advantage? So here, if it is normal system, you can see the marker boards. You can able to send only one train between the marker board. You consider that is a section. You can send only one train in the marker board. With the virtual block section, you can able to send, you can able to follow the one train within the other by using the hybrid level 3 solution. It is cost effective. We don't need to have multiple axle counter or the track circuit which is required for the train detection, and also it improves the headway, and it is mainly used for achieving the better headway and operational efficiency. This is the key highlight that we had deployed in ETCS level 3 hybrid.
So a couple of remarks here. The key feature of hybrid level 3 is the virtual block sections. This is the reference to level 3 because level 3, ETCS level 3 was meant to have so-called moving block, and the way to implement this normally is by use of virtual block sections, and that's what's done in hybrid level 3. Why is it called hybrid? It's called hybrid because in this system concept, you actually have a mix of virtual block sections and fixed block sections. So you can operate trains that are not fitted with the hybrid level 3 feature, that cannot work with virtual blocks. They can still operate on the existing fixed block sections that are kept in the layout. And all the trains that can work with virtual block, they can operate at shorter headways at higher capacity by utilizing the virtual block sections. Now, a second thing that I want to remark here is that the original intent was to achieve higher capacity by introducing shorter virtual block sections in between the longer fixed block sections. But there's another potential advantage for railways that cannot afford to have fixed block sections everywhere. I'm thinking, for example, remote regional areas where the maintenance of track circuits would be very, very onerous and expensive. And hybrid level 3 would offer an opportunity to get rid of fixed block sections of track circuits or axle counters in areas where it's just difficult to maintain any trackside equipment. So that's kind of a side benefit, and it has an historical background as well, because a previous concept called regional ERTMS was very similar in terms of a concept to ETCS level 3. So using the idea of virtual block sections of hybrid level 3 for low equipment regional railways is not new, but maybe it's an interesting transition of an old idea into a new environment. So now we're going back to Vijay's presentation in the right sequence. I show you a number of clips from that presentation, and then I give you my comments on each clip afterwards.
This shows the ETCS level 2 architecture, where we have a radio block center, we have a digital interlocking, and we have track elements and the onboard computer. What we are seeing here, our system has been developed in such a way to go for the scalable architecture, which means it can be easily adapted to the next generation requirements for the ETCS solutions, where the specification has been defined by the UNISIC. It is upgrading from baseline 2.3.0. Now we are working on 4.0. Right now the operational baseline is 3.4.0. So our solution is scalable and it is moving towards the next level. It incorporated ERTMS Moon platforms, which is for our interlocking, and it can also manage a GSMR to LTE, which is the future FRMCA specification, which is going to come in the future.
So from this clip, what's pretty important to note is that it's important for ETCS products to be upgradable to future versions of the standards, because the ETCS standards are constantly moving, are constantly evolving, and especially for this project, this is very important. As Vijay mentioned, the project was awarded according to the latest version of the ETCS baseline at the time, and that was the so-called baseline 3 release 2, according to the system requirement specification version 3.4.0 that Vijay mentioned. However, the project required a number of features that were only formally specified in a later version of the ETCS standards, the so-called baseline 4. And now the Alstom products used on this project need to be upgraded to the newer features of the later version of the standards.
Imagine a train moving from Rome to Copenhagen across Germany with seamless operations. So which one ETCS onboard system which can able to travel across all the the cross-border challenges with the ETCS level 2, where the driver can able to move without any challenge, which means each Schengen state has the different signaling system, but ETCS system has unified into a single one, which can able to manage the complete movement, and then it is increase the seamless operation and the driving experience.
In this last clip, Vijay mentioned interoperability for the first time. What he was describing was an ideal scenario from Europe, where cross-border traffic all across Europe can be done seamlessly. However, experience from Europe shows that it's not quite that straightforward, and we will get back to that whole topic of interoperability later during this episode. Stay tuned for that.
And we are also moving towards the product vision, which is the ATO, which is the fancy word in the mainline, because the specification is released only last September. But already the customer are ready, or they are ready, they want to implement ETCS with ATO. So with the draft specifications, we had even developed the ATO, which will be adapted soon in the project what we are going to talk about in the NCRTC. And then centralized control system, the traffic management system, which is going to adapt the requirements, and then it's not only the infrastructure, it is the planning. So it will be managed by the TMS system, which is going to interoperable, and also it is going to be support to the multimodal system. And what we are talking about is the synchronization. Whatever the infra we have, it should be planned in such a way that it is connect with the people and the operators and for the passenger operations.
I've been saying for a while in my ETCS trainings, for example, whenever you try to make ETCS better performing, it needs to be more similar to CBTC, communications-based train control, because CBTC simply is the gold standard for performance of a signaling and train control system. And two aspects described in the last clip that are used for this ETCS application in Delhi are automatic train operation, which is also called ATO over ETCS, and the second one is a tightly integrated centralized traffic control. Some people call it traffic management system. In Sydney, for example, for the digital systems program, this is called traffic management system. The trick is to have a centralized control system that replicates features from the CBTC world, what's in CBTC called automatic train supervision. And while this is not explicitly mentioned here, I think that's the idea behind this whole concept, making ETCS look more like CBTC. You may also have noticed that the word interoperability was mentioned once more, and as I said, I will get back to that.
We have different products for each of our solution requirement. Atlas 100, which is now replaced with Onvia. Atlas 100, Atlas 200, which is now Onvia 200. And what we are deploying right now in many of the places is Onvia 200, which is ETCS level 2. And future, it will be with Atlas 500, which is ETCS level 3 hybrid, where we are discussing on mainly for the suburban network.
This last clip was a quite important pickup with regards to Alstom's branding of ETCS products. So you see that they used to be called Atlas 100 for ETCS level 1 and Atlas 200 for ETCS level 2. The name is now changing from Atlas to Onvia. I don't know why. Maybe Alstom thought that after more than 20 years of Atlas products for ETCS, the brand needed some kind of facelift. I don't know. But it's definitely worthwhile noting that Alstom ETCS products in the future will be called Onvia 100 for ETCS level 1, Onvia 200 for ETCS level 2, and as we learned, Onvia 500 for hybrid level 3. So this is not a replacement of products, it's just a replacement of the name of the product.
We are also working for Australia and the digital system project on stage 2B and also the stage 1A with the with the ETCS level 2 solutions.
So from the longer presentation about Alstom references worldwide that I didn't want to share in this podcast here, I just took the clip with the reference to what's happening in Australia, specifically in Sydney. So you heard Vijay talking about stage 1A and stage 2B. So this is part of the digital systems program that was already covered in the first part of this episode with the other presentation. Alstom, as I said, is the second trackside supplier in Sydney. What I want to emphasize here is the strategy that Sydney is pursuing in order to create a supplier base of 2 trackside suppliers. They're doing this by giving each one project, a pilot project if you will, or they call it early deployment schemes, to both suppliers. So Alstom is getting the stage 1A, which is a line from Erskineville to Bondi Junction, and Siemens is getting stage 1B, which is the line from Sutherland to Cronulla. But while they are implementing these first stages, both suppliers do separately, they have already gotten orders for a second stage for a much larger project. And again, each supplier got one project each. So Alstom is getting stage 2B and Siemens got stage 2A. So that's a prime example how you can maintain your supplier base by giving them an ongoing pipeline of work, one for each supplier.
ETCS trackside can be one supplier and onboard can be one supplier. It's not only interoperable between the states, it also interoperable within the suppliers. So onboard can be a one supplier and then trackside can be another.
Well, there we go. Another mention of interoperability for at least the third time, maybe even the fourth time during the presentation. And I was wondering why there was so much emphasis put on interoperability, especially given that it could be a potential future problem for this project in India. Stay tuned, I will get back to that.
So they want to deploy a first ETCS level 2 project in India, but with the latest specifications, which is not even ready that time. which means we are working on ATO now, but in 2018-19 we don't have the ATO draft. We have only the ATO draft specification, and they also want to deploy with LTE. They also have they want to deploy only the ETCS, but with the interoperable solution which covers the network.
So now we are starting to get to the bottom of where I see potential problems in the future. You heard Vijay mentioning in the last clip that the client wants features of ETCS that didn't even exist as part of the standard at the time when they awarded the contract to Alstom. So Alstom is kind of working on a shadow version of a future standard, functions such as, for example, ATO over ETCS, but also the use of LTE for radio and not the previous radio standard for ETCS, which is GSMR. So, and all these new features are at the moment unique for this project in India, but at the same time, the customer understandably wants interoperability between multiple suppliers. So now the trick will be to have a unique application replicated by other suppliers. And we will get to see where that might pose a problem for the future.
So if you see on the corner the side, so you have total 8 lines has been planned by the Indian government to mainly to have interoperable and connecting the various states, and Delhi is the capital hub to have the multimodal system. So right now we had working on phase 1, which is Delhi to Meerut, 82 kilometers of line and with 40 trains. So Alstom has been awarded this project, and we are also the responsible for rolling stock and also for the signaling part, including ETCS, interlocking, and then traffic management system. Okay, and the other the key highlights of the project. In India, this is the highest speed, which means 180 design speed, and then we also achieved the operational speed of 160. That too, it's a fully a greenfield project, and we have to deliver within the 3 years of time. This was the quite challenging milestone that we had to work on the customer requirements. So the total corridor, which will cover around 312 kilometers for the 8 corridors, and then with handling of 231 trains. So this project has been awarded to Alstom in 2021, and you can see the customer has very challenging requirements which has been deployed to us, and then the vision for him to deploy and in a very short period of time. So it is the India's first ETCS level 2 project and the fastest for India with the speed of 160, and it is for the mixed. They are also having the suburban network and also for the high-speed line within the 8 corridor sections. And ETCS, they want to deploy ETCS so that they can have the multiple vendors able to deliver the solutions.
So again, we're getting closer to the potential problem here that may arise in the future. You have seen from the last clip that the total vision for the regional rapid transit network around Delhi is to have 8 lines. Of those 8 lines, only 3 are committed at the moment, and only 1 is under construction, which is Delhi to Meerut. And for this one line, everything has been given to a single supplier, which is Alstom. Everything. The entire signaling, ETCS trackside equipment, ETCS onboard equipment, the radio system, even the trains come from Alstom. Another important thing here is that this project was done under quite a bit of time pressure, which Vijay mentioned in that last clip, which may have consequences with regards to the implementation of that ETCS solution and also the documentation as far as a future use by other signaling suppliers is concerned.
And then high availability also required as a part of ETCS level 2, even though ETCS level 2 is a highly reliable system, but deploying first time in India, they also want to backup system of ETCS L1. And all operation monitored through our control center, which is the TMS. So during this period, we had been deployed ETCS till the time we were deploying ETCS with GSMR. GSMR, which is a network which is required to communicate between the trackside system and the onboard system. It is the dedicated network for GSM railways, which is a dedicated network which requires a communication between onboard system and the trackside system to send the movement authority. But in this project, Indian government could not get the GSMR spectrum, and the spectrum is not available. They want to use the LTE, and by the time we don't have the specification ready for the for the LTE, which is adapted. The baseline and the future FRMCS, Future Railway Mobile Communication System, which is still in draft, but we had developed our products aligned to the draft specifications, and we were able to meet the requirements, and which helped the project to execute in terms of the railway.
The last clip mentioned yet another specialty of this ETCS application, which may make it a little bit more complicated for other suppliers to replicate in the future, and that's the backup of an ETCS level 1 system. This is not at all a standard application of ETCS. Having level 1 as a backup for level 2 is quite unusual these days, and there are many ways how this application can be customized, where there are specific things in there which would not be exactly the same for each and every supplier. So that means that a future supplier that's not Alstom will have to replicate the Alstom solution for this specific ETCS application, and this is something where I see problems. The other important mention here is that this project is using LTE radio, and LTE is not the standard ETCS radio. The standard ETCS radio is GSMR still today. So what's happening there happens for two reasons. One is Vijay mentioned that they didn't get the licenses for the spectrum required by GSMR in India. So that was one reason why GSMR didn't really work for this project. The other reason is that GSMR is an aging technology. At the end of this decade, it will be no longer supported by the telecommunications industry, and therefore using LTE radio is definitely a more future-proof solution, because the future radio for ETCS will be based on LTE, on 4G, or maybe even on 5G.
Platform screen doors is quite common in the urban solutions. Even Alstom has been deploying for so many years and so many projects, but in the mainline we have deployed this one with the integrated solution, not as the third party. We have integrated solution. We define the packet, the user defined packet, the packet 44, which is so much technical, but okay, I will tell you, it will be defined within the Alstom. The packet is defined, and that we had deployed, and even this packet is being interoperable. If the next corridor, if someone is going to deploy, we will share the specification if they adapt to it, and it can be an interoperable solution as well. So deploying ETCS solution with the packet 44, again, it's the first time for us to deliver.
So what can you say? The list of specialties for this ETCS application becomes longer and longer. Now we're adding platform screen doors, which are very, very uncommon in a mainline environment where ETCS signaling is applied. So what Vijay mentioned is they're using packet 44, which is part of the ETCS language, of the standardized ETCS language. They use packet 44 to control platform screen doors and have ETCS communicating with platform screen doors. So that's fine, but still it does require any future supplier to adopt this kind of interface and also make changes to the interfaces of their existing ETCS products, both for the trackside and the train-borne. So the very least that's going to happen is that a future supplier would have a price disadvantage against Alstom because Alstom has already done this interface adaptation work. So for them, it's simply a repetition of an existing solution, whereas any new supplier, any future supplier would have to go through all these initial adaptation developments. And of course, they don't do it for free. They would have to price it in. So in a future competitive situation, you would have an Alstom offer, which is very likely to be cheaper than any offer of a competing signaling supplier, simply because they need to cost in one-off efforts that Alstom has already covered with the first project.
The 82 kilometer is fully elevator line except 20 kilometer which is underground. It is completely a new build. And right now, stage 1 and stage 2 has been handed over to the customer. And stage 3 and stage 4, which is due on April next year. That includes ATO as well. Right now, it has been not, ATO is not included, but we had included PSD and the next ETCS level 3 hybrid solution of virtual block.
So in this last clip, it was mentioned for the first time that ATO is not yet implemented. It will only come in the next stages early next year in 2025. That gives you an idea how new that feature is. The specifications for ATO over ETCS were only finalized and ratified in August last year when the latest version of the ETCS standards came out, baseline 4. And that means that there is ongoing development work to implement this standard compliant solution of ATO over ETCS, but not compliant with the original standard of this project, because for that version of the standard, ATO didn't even exist, wasn't part of the standard. But from a WART point of view, future version of the standard. So you see clearly the complications there. I mean, the client in India really went cutting edge there. That was not just leading edge, it was really cutting edge. But you can also see the challenges that arise from this kind of future-oriented approach.
Normally, any project, if you see, this is the key functions that we will provide, ETCS level 2. But in this project, what we had deployed is the grade of automation, which we are going to deploy is GO2, which includes the train driver assistance for the ATO, which enables, for the better efficiency and then, better time management. And then line ATC system, which is ETCS level 3 hybrid, first time we were deploying. And we are also having ATO and PSD, and our target precision to stop the train in the main line is 300 mm. Right now, without ATO, we were managing at closely around 750 mm to 800, which enables, for the platform screen doors also to manage. And right now, this is one challenge we are also facing to implement the ATO, where we will improve the stopping accuracy as well. And okay, we also have ETCS L1, like I said, degraded mode. We had been having a ETCS L1 system.
So this last clip showed a nice overview of all the special features of this specific ETCS application. So you have hybrid level 3, that means virtual blocks. You have ATO over ETCS. You have platform screen doors. You have the use of LTE radio, which still is a non-standard ETCS radio. And you have the train interface to the Alstom trains, which will be novel or different for each and every future supplier. So the issue that I can see here coming up when it comes to the procurement of the next stage, the next line of the regional rapid transit network around Delhi, from Delhi to Anwar, that's the second project that's on the card. There will be a competitive tender situation. I'm pretty sure that Alstom, as the incumbent supplier of the first line, will bid for that second project as well. And what's going to happen is that the client will have one supplier, which is Alstom, that has a ready to deploy solution where all the specific things have already been implemented for the first project. And all the other suppliers will require a one-off adaptation development to replicate the Alstom solution for this specific client. And that may lead to a situation where the railway organization may almost be forced to give the second project as well to the supplier of the first project. That has nothing to do whether it's Alstom or anybody else. This is just a normal way how things can pan out if a railway organization starts a rollout program with only one project and only one supplier.
Another, the next generation product we had deployed in NCRTC is EVC, European Vital Computer 3, which has the key element to support FRMCS, which means LTE. It can able to, it is able to not only with the GSMR, it can also able to, communicate in the LTE network. And it is the remote diagnostic system which can able to manage, and also the solution wise the cubicle which we have reduced 60% in order to have a, the smaller space requirement in the trains.
That last clip gave a couple of important aspects of the onboard computer for ETCS. So number one, and this is really relevant where a future radio solution will be introduced for ETCS. That's called FRMCS, the Future Rail Mobile Communication System. So for getting the migration right from the old GSMR radio to the new FRMCS or to the LTE radio here in India on the project, it's very important to have an ETCS onboard computer that can communicate both via GSMR and via other radio technologies such as 4G, 5G, things like that. That's really, really important. And as you heard in the last clip, that's one of the features of the new or the current product that Alstom has for the ETCS onboard controller, the EVC. The other thing that's remarkable is the size reduction by 60%, which is significant. But having said that, from my knowledge, Alstom previously had the biggest onboard computer cubicle in the market, and that was often a problem for finding installation space on vehicles. So making the 60% smaller is certainly a very smart move and may make this onboard computer more applicable for a wider range of trains and locomotives.
So generic offerings normally we deploy, which is ETCS with GSMR, includes even in Australia we were been deploying with ETCS with GSMR. But what the future it's going to be with functionalities similar to urban network, which means platform screen doors like in urban, and we have LTE and also open to the public network, which need to be a dedicated network. And also we can have hybrid level 3 system, which will help us for bringing the headway.
So again, this last clip gave a nice overview of the many features that are first offs for Alstom. So chances are that for any other supplier coming later onto the same program in Delhi, it would also be first off applications, plus they need to replicate the solution that Alstom has already developed. And I wish the client organization all the best for future procurements, but they really need to think hard and fast how they manage to introduce a second supplier without discriminating the existing incumbent, which is Alstom. And that is certainly a challenge that you wouldn't find in Sydney for digital systems, simply because they started off with 2 suppliers right from the get-go, having 2 pilot projects, not just one, and giving 1 pilot project each to each of the 2 identified trackside suppliers.
In one sentence, what is the key difference between ETCS 2 and 3? One sentence.
One sentence. ETCS level 2 is a fixed block system, and ETCS level 3 is moving block. And we had not deployed, and no one has deployed ETCS level 3. It's not about, we don't have the solution. We have the solution, but customer is not ready to deploy ETCS level 3.
Well, I absolutely had to finish this episode with this last clip because of that one statement that no supplier has to date implemented ETCS level 3. I have been saying this for years. I have been on the bandwagon for years, fighting against claims that some supplier has implemented ETCS level 3 anywhere. It has just not happened. And the reason is not so much that the clients are not ready for it. The reason is that there are no interoperable products for ETCS level 3. And I do not say this changing anytime in the future. So the best approach that the industry has is adopting the virtual block sections of hybrid level 3 into the ETCS standards, and then have interoperable solutions on that basis, and not running behind an ideal of moving block ETCS level 3, which I still think is a pipe dream. Now, with that said, I hope you enjoyed today's format of the podcast. Next week, we will be back to having a guest on the show and having a conversation according to the title of the podcast. Again, if you like it and if you think that there's somebody else who could learn from this episode, which was almost a masterclass about modern advanced ETCS applications, please share it with your friends and colleagues. I see you again next week. Thank you for listening or watching. Hi, this is Doc Frank. I need to tell you about my brand new cutting edge 2024 training, Digital Signaling Interoperability. Interoperability is such a huge issue, not just here in Australia, but in other countries as well. Everywhere where you've got different railway authorities with cross traffics between each other. This course has the latest insights, the latest research. This training includes the SPA framework, Systems, Products and Applications, which creates a lot of clarity and avoids confusion in that area. We then look at the different technologies for digital signaling in Australia. And this is just an example that is transferable to many, many other countries in the world. We then give detailed introductions to the main technologies used in Australia, which are CBTC, ETCS and ATMS. Then we discuss the hierarchy of interoperability controls, the different ways how interoperability can be handled and addressed. a special session on CBTC interoperability between CBTC products from different suppliers. Then we look at ETCS interoperability, and if you think that comes automatic just by using ETCS, you need to think again. This lesson will address how interoperability in practice can be achieved with ETCS, and it does require some work. And then lastly, interoperability between different technologies. What is required to do that, to achieve that? Which options are available, and what is arguably the best? You can get access to this fantastic brand new training under docfranktraining.podia.com/interoperability. I repeat that again, docfranktraining.podia.com/interoperability. If this is a topic of concern for you and your Revware organization, then don't miss this training. Hi, it's Doc Frank again. I hope you liked today's episode. I like to keep it as simple as possible, so I only have one single request for you. If you like this podcast, please tell your friends and colleagues about it. That's all I want, because that's a service that I'm providing to the industry, and I would like as many people as possible to listen to this podcast and learn something from it. So please share. And until next time, keep it simple and bye for now. Thank you for listening.